So the first set of questions, the first video, was all about introducing you to delta H and then emphasizing the fact it's an extensive property. It is expressed as a molar quantity associated with the chemical equation. So first question, which process is endothermic, needs heat? Well, the only one of these that needs heat is vaporization, because solidification is freezing. Freezing is the opposite of melting, and so melting you have to put heat in is endothermic, thus solidification or freezing is the opposite, it's exothermic, gives off heat. Condensation is of course the opposite of vaporization, so gives off heat, and freezing is the same as solidification. Now we have a question associated with the molar quantities. Okay, the combustion, 1 mole of methane, produced carbon dioxide and water, releases 802 kilojoules per mole. When 3 moles of oxygen react with methane, what's delta H for the reaction? First of all, let's make some pretty colors so we can point it out. Always try and get yourself an equation if you need one. So we're told we got methane, CH4, produces carbon dioxide and water. So there are our products, and combustion is of course reaction with oxygen. Balancing it, I'm not going to dwell upon the balancing, you can go back through the stoichiometry modules if you want to see that, but 2 O2s and 2 H2Os. So what this is telling us is that when we have 1 mole of methane, 802 kilojoules per mole, 2 moles of oxygen, therefore 802 kilojoules per mole. Okay, so the heat change when we got 2 moles of oxygen, 802 kilojoules per mole is minus, because that is heat released. It's an exothermic reaction. Now, various ways to do the rest of the question. I like to set it up as ratios. We've been asked for what is the delta H for 3 moles. So what is the delta H for 3 moles? We do know that 2 moles has a delta H of minus 802 kilojoules. So you just match it up in the little ratios. Solve the equation, and delta H for that particular one, for 3 moles of oxygen reacting, minus 1203 kilojoules. Same idea here, 25 grams ethane burned in oxygen, or 1.3 times 10 to the 3 kilojoules heat is released, so that's a minus heat change again. Using this information, determine the enthalpy change for this reaction. So let's put some pretty colors in there. Now, 2 moles of ethane, which is what we're looking at here, okay, is equal to 60 grams. 1 mole of ethane, 24 plus 6 is 30, so 2 moles is 60 grams of ethane. So again, we're told 25 grams of ethane gives us a change of minus 1.3 times 10 to the 3 kilojoules. We're asked for what is the heat change for 2 moles, in other words 60 grams, so set up that little ratio. Okay. And then the delta H for that whole reaction, 3120. However, it told us that this was released, so therefore really I should have put in minus 1300 there. Not any big deal, I would just put the released in there and change that then to minus 3120 kilojoules. Okay, delta H is a molar quantity. Thus, if you know the heat change for a certain amount, you can always relate that to moles and get delta H for the overall reaction. Conversely, if we know delta H for the overall reaction, which is associated with the number of moles, we can calculate the heat change for any amount of any of the substances involved in the reaction. Hope that helped a little bit.